Hello everyone, I am Rahul, and this is the final video that I am making on RoxKV and RoxAI. So, over the past couple of months, the project grew from a simple key value database to a much larger system which involved TCP networking. As we saw on the previous videos, it is compatible with Redis now using RESP compatibility. It includes PubSub and now it includes an AI agent layer. So in this video I want to show some final updates, and that's something that I made over the past few weeks, and explain how the major components that work together. And so this will be the final video that I will be making on RoxKV. And let's start with the agent layer and the updates that I made on it recently. So let's start with the abstraction layer. So the first major addition that I added to the RoxAI was, originally I built it around Olama and local models. So so it was like all the tools that were executed was through Olama's local model reasoning, but then I wanted it to become system independent, for not so that it doesn't depend on any single provider. So I added these four providers: Gemini, OpenAI, Grok, and Olama was already there. So the user can configure the provider and model, and RoxAI handles the provider specific API communication behind the common interface. So the master agent doesn't need to know whether the request is going to which provider. It just have to execute the specific function or the tool that is being called by the provider. This keeps the agentic layer, which is, sorry about the so this keeps the agentic layer separate from the provider layer, so such that there is like independency between them. Second I implemented was semantic tool router. So previously I planned on building a RAG around the tools, so that the query queried by the user will first go through the RAG, take out the relevant chunks, and then get the specific tools it require, and then those similar to the tools extracted from the similarity search would be sent to the LLM. Previously I planned that, but before that I built the semantic tool router. So when I used the semantic tool router, I came into the conclusion that RAG was unnecessary at this point. So I kept the semantic tool router, which would there are almost like 45 plus tools provided to the LLM. So it tracks down the tools limited to the top 5 tools for now, to reduce hallucination and context window for the AI. So the context size, it also helps with that. I got rate limited most of the times, because it would just get out of the tokens, like rate limit the token inputs. So once the model receives the selected top k tools that the semantic tool router narrows down, it can decide which tool to execute and provide the relevant argument to them. So overall the flow becomes user queries the query becomes the user here would query the agent and the provider. Before it reaches to the provider, it first reaches to the semantic tool router. The router narrows down the tool, and then it is sent to the provider along with the query. The LLM provides the final response, and the executes the tools as required. Then I also built a failover mechanism. So it was while I was building the abstraction layer, I came into I saw that once, like when I was testing with Gemini, so I was getting rate limited, and the database was failing all along and wasn't responding well. So I built a failover mechanism that if a selected provider fails, let's suppose Gemini's connection fail or a service fail or rate limits, the system attempts to uh, you know try another configured provider. Like if you have all the 4 providers configured, so if and you are using Olama, if Olama fails, it will try with Gemini, and then it will try with OpenAI, until it gets a successful response. Once it gets a successful response, it will respond back to the user, and if all the 4 of the providers fail, then it will simply return the failed response to the front end, and which we are going to see in a while. So let's go to the dashboard, and let me show you the updates. And so, as I have shown you all of this in the first video, this is the new component that I have added, the LLM manager component. So it is defaulted to Olama, but you can change it through the configurations through here by selecting the configurations. And I have already started the servers, the Olama server, and all of this. And this is the Redis CLI. Let me okay, so here we will connect with directly to the CLI. Okay, so as I showed you this, I will just switch it to Gemini for now. I have already configured it, given it the API key and the endpoint. Then I have set the max tokens, the top temperature, and the timeout settings. I have saved them. Now I will just query something. Okay, so let's start with another one. So okay, let's query this, and as you can see, it is saying that we have currently 9 active connections, and so we have that too, as well as 3 are those, 4 are those, that's 7, and 1 itself, and 1 is this one is communicating directly to the RoxKV, and that is why it showed 9 active connections. Now I will show you something that is, like, I think is a really cool thing. Subscribe game. So it's like the pops up, that is what okay, for some reason. Okay, anyways, I have subscribed to the channels. Now let's see if that works. Broadcast to all the channels. Topics. This is the LLM messaging. Now if we go here and wait for a second, as you can see, all 3 of them received the message and the tool executed properly, and as you can see, it replied with the LLM messaging has been successfully broadcasted to all the topics, and such. You can change with like you can use the Olama, but Olama takes a lot of time on my laptops because it's a little laggy, as you know. So that's that. And as on the previous video, I showed you the Redis-compatibility, and since this is the final video, I would just slightly revisit the things like this, and just show you that it is working. I showed you on the second video that I have actually integrated this to the project, and it worked, and that's a great milestone for me. like even though I am not matching the speed of Redis as is, it is built on Go, Redis is built on C, so there is no way it is faster than Redis. Either way, it is in a acceptable amount, in a, you can say, in an acceptable amount of speed time, it is replying back to the server, and that's a good thing, I think so. So that's that, and overall this is the architecture. Sorry about that. Yes, overall this is the architecture, and so if I have to sum up all of this, RoxKV handles the complete database operations completely and keeps it in the byte format for faster transmission through the TCP, and the RESP layer handles all the encoding and decoding here, and communicates with whatever is asking the commands to. And the RoxAI layer, this sits on the middle of the database and every client that it tries to connect to it, and handles all the reasoning flow, semantic routers, narrowing all the tools, and the abstraction layer allows you to communicate using all the different LLM providers that I have, and used without changing the core agent topic, so logic, sorry. uh, and the dashboard provides the interface, like this one provides the interface to interact with you while configuring all the system. As you can see, it is pairing, and after a while I think it should provide me the response. So yeah, as you can see, it provided the response in pretty good format, and so overall that's that. You can visit to this URL, which is like, you can go to this GitHub repository. I have added the docs page here, and you can clone this, use it on your own. I am not claiming that I have built another Redis. I am just claiming that I built something close to Redis, and not as much command as it has, but enough commands to integrate with it with a normal MVP project. And this is the documentation page. You can see all the installation commands here through Docker, through manual build and pre-built binaries, and you can go here for the RESP documentations. You can read through all of them, all the architecture, RESP protocols, commands, and if you want to see any how it works, everything. Now if we go back here, so these are all the capabilities and actions I have put together. So, and this is where I am going to stop with RoxKV here. So like, this project started with a simple key value database, and over the past couple months it evolved into something much larger than what I originally planned. And I'm going to keep the project open source so that anyone interested can explore it, experiment with it, and contribute to it. I'm also going to move on to my next phase of the learning, particularly more on AI engineering, and understand these systems at a deeper level. But so this is the final video, and that's RoxKV and RoxAI for me. And thank you for watching till the end. Thanks.